I mean, it's fine as it is. I'm just... Let's look at a different one. Example 4, right? This one will be relatively easy. Limit as x approaches 6 from the right of the square root of x minus 6. What would this be equal to? So you know, if you there are various ways to analyze limits, but one of the ways I do is I'll put like, okay, so if x approaching 6 from the right, that means x is equal to like 6 plus delta for a little delta greater than 0, right? So if I look at the square root of x minus 6 in that limit, what I'm really looking at is the square root of 6 plus delta minus 6, which is the square root of delta. So how does that work? I mean, what's the square root of a very tiny positive constant? It's something very small and positive. It's very close to 0. I mean, this works out to 0.
Zero?
It's 0, yeah.
Oh.
And of course, you can also see that graphically because this is the graph that starts at 6 here. I mean, this is y equals the square root of x minus 6, yeah? Because you take the square root graph and shift it 6 to the right if you want to think about transformations of graphs, but... So, I mean, you can either think graphically, you can think about plugging in points, like really close to the limit point. That's a good way if you're not sure, you know, try plugging in a number that's 0.1 away from the limit point, or 0.01 away from the limit point. You can pretty much figure out limits with that. However, be careful, the indeterminate ones, you need to show algebra for, right? And also the indeterminate ones, if you plug in numerical stuff, it can be deceiving. So that's kind of the larger point, is just plugging in numbers can be deceiving. So you have to kind of put it together with common sense. Now, oh, I'm sorry. You guys shouldn't erase already. Sorry. Two more examples, and then I'll let you go. I'm trying to. These examples are intended to help you with the homework. How about this? Limit as x approaches 2 from the right, or from the left, let's say, of 1 over, well, x plus 3 over x minus 2. How would this work out? So we've worked ones today so far that they worked out for the most part, and this one's not going to work out. See what happens as you plug in 2. It's going to infinity, right? But the numerator is going to 5, right? The denominator is going to 0. So this is type like 5 over 0, which is not an indeterminate type. It's not indeterminate. All right? Yeah, it's going to blow up. The question is how, right? Because we can do better than just say it doesn't exist. We can tell, maybe we can say it's infinity, we can say it's minus infinity, right? So I'm going to do this from both sides. So there's different ways you could handle this. You could think about actually plugging in values, right? But I personally like to set, you know, x is equal to 2 minus delta for delta greater than 0. for this one. And for the second one, I set x equal to 2 plus delta for delta greater than 0, but delta super tiny. That allows me to analyze the limit, you know? And so as I look at x plus 3 over x minus 2, what's that give me? That gives me 5 minus delta over delta. And for this one, x plus 3 over x minus 2 works out to 5 plus delta over minus delta. Excuse me, I think I've got those backwards. This one works out to delta, this one's minus delta, right? Because, see, I just plugged in like 2 plus 2 minus delta. Do you understand why I'm saying plus or minus delta? If this is the limit point 2, right? If we're approaching 2 from the left, we've got a point here like 2 minus delta, right? On the other hand, if we're approaching 2 from the right, we've got a point like 2 plus delta. And so if I want to understand how those limits behave, I can consider such points for delta very small. Or you can get out your handy-dandy graphing calculator and graph it and see what happens. So you guys tell me, 5 minus, if delta is like almost 0, but not 0, but close to 0, right? Then 5 minus delta is pretty much 5. So we've got 5 divided by a super tiny negative number. So this is essentially something arbitrarily large and negative. So this first one is minus infinity. Whereas the second one is 5 over some very, very small positive number. That is something that's huge. That's infinity. Now, if you graph this function, if you looked at it on the graphing calculator, what you'd see, right, is that this thing has a vertical asymptote, right? And basically, it's going like, its graph looks something like this. So it's going to positive infinity from the right, and it's going to negative infinity from the left. When I said 2 more examples, this was one of the examples. Oh, I'm sorry. You'll forgive me. I sometimes misconstrue students changing pages for packing up bag, and you guys are fine. Ignore me. Okay, so the other problem in the homework that I haven't done anything quite like in class yet was there's one that has a case-wise defined function, right? And I ask you to find a limit, a constant that makes the limit work. So I'm going to work something very much like that, but different. Suppose we had 3 plus x over cx cubed plus 2. And this is for x less than 4, and this is for x greater than or equal to 4. All right? The question is, what c do we choose to make the limit as x approaches 4 of f of x exist? So what did we say earlier this week? We said for the double-sided limit to exist, we need what? We need the left and the right limits both to do what? They must both exist, right? And they have to match up. So the way to solve this kind of problem is to look at the left limit and take a look at the right limit separately and then make them equal. I put a constant in it, so we'll be able to choose the constant to match them up. So you guys help me out. I'm going to do limit as x approaches 4 from the left of f of x. Can you tell me what I should write then? And see, this is where the definition of the limit starts to become important. What does limit as x approaches 4 from the left mean? we're looking at values, what? To the left of the limit point, right? That means x is what? Less than 4? So what do I have to write? What's the formula for f of x in this case? Do I use 3 plus x? Do I use cx cubed plus 2? Which formula do I use? Which case am I in? Use the what? This, but but this implies that x is less than 4. Because we're approaching from the left. The first one. 3 plus x. And can you guys calculate this limit? You should be like, I would like for test 1 to be all of this kind of limit, please, right? 7, right? Yeah. Now, how about the other side? What's the limit? X approaches 4 from the right of f of x. Now I have x greater than 4 in the limiting process, right? I use the other one, cx cubed plus 2. And again, this is a polynomial, right? So like I was saying at the start of today, we just plug in the point. Yeah, c times 4 cubed, which is 64. 4 times 16, right? Yeah, plus 2. But remember our theorem? The double-sided limit only exists if the left and the right limits separately exist and match up. So for the double-sided limit to exist, we need to set 7 equal to 64c plus 2. Interesting. So apparently 5 is 64c. So c is what? Yeah, 5 over 64. But yeah. Now, graphically, what's the meaning of this? Like, what are we doing? If you want to take a step back graphically for a second here, what's 3 plus x look like? That's a line with slope 1, right? And it has a y-intercept of 3. So it looks like that, right? And what we just did is we picked a value for c such that this cx cubed plus 2 starts there. So they match up at 4. That's what we've done. Now that doesn't, your homework doesn't ask you that, right? But anyway, I hope that's enough to get you guys started. If there's one, like the last, problem 16 in the homework is on a quadratic epsilon delta problem. I haven't done one like that in class, but there are ones in the notes that you can kind of like generalize from. And also, I will include some bonus points in the homework from here to there. So like you can skip a problem every so often, it won't hurt you. So if you're not interested in problem 16 in the homework, like feel free to skip it, all right? Anyway, have a great weekend, guys. And I will put the desk back. You guys don't worry about it. I got it.